In any progression, nth term is related to its previous three terms as following. Then find the value of a1 plus a2 over 2 plus a3 over 2 squared and so on. You are watching Brain Exploders, the world where brain starts working. First three terms of the progression are 1, 1 and 3 respectively. Using these three terms and the given relation, we can find the fourth term. Similarly, with the help of second, third and fourth term, we can calculate fifth. In this way, we can find other terms. We will discuss about a general formula for nth term also. On taking all the terms to the left hand side, we get an minus 1 minus 2an minus 2 plus an minus 3 equals to 0. It will help us later. Suppose the required sum is equal to s. Let the nth term of this series is bn equals to an over n minus 1th power of 2. So s is equal to summation bn from n equals to 1 to infinity. Now start with the given relation. Divide both sides by 2 to the power n minus 1. Replace the terms of given sequence with the terms of our new sequence using the assumed relation. Apply summation both sides from n equals to 4 to infinity. We started from 4 because n minus 3 must be greater than or equal to 1. First sequence is starting from b4, hence it can be obtained by subtracting b1, b2 and b3 from S. Next sequence is starting from b3 and therefore it can be obtained by subtracting b1, b2 from S. On further solving, we get S equals to 8. Here is an alternate solution. Let fx is equal to a1 plus a2x plus a3x squared and so on. Here x must be less than a particular value so that the series becomes convergent. Form three different equations from this equation by multiplying x, 2x squared and x cubed. Place the same powers of x under one another. Subtract the first two and add the third equation to the original one. If we look at the coefficients of any power of x, we find that together they are equal to 0. We have selected such multiples knowingly. It will be more clear if we use actual numbers. You can see that sum of coefficients of any particular power of x is 0. From here, we get fx equals to 1 over 1 minus x minus 2x squared plus x cubed. This is not true for all the values of x, but it is true for 1 by 2. Put x equals to 1 by 2, we get the required sum equals to 8. Here are some concepts related to this progression. In this progression or in any such progression in which terms are related to some finite number of previous terms, ratio of consecutive terms tends to a constant value as n tends to infinity. These are some ratios of consecutive terms. Observe them. They are increasing and decreasing, but they are oscillating about a value nearly equal to 1.8. And as the n is increasing, their value is going more closer to 1.8. Ratios of consecutive terms tend to r, so the ratios of terms at a difference of 2 and 3 places tend to r squared and r cubed. On putting these in the given relation, we get a cubic equation in R. A cubic equation has three roots, but the ratios are tending to only one value. How can we decide to which value the ratios are tending? It is the value whose modulus is largest. Not here, but if you find that a complex root is having largest modulus, you will also find that ratios are not tending to a fixed value. Let's derive the general formula for the nth term. Start with the equation having the coefficients same as in the given relation. Suppose its roots are r1, r2 and r3, r1 having the largest absolute value. Multiply both sides by r. Put the value of r cubed. Again multiply both sides by r. Again put the value of r cubed. In this way, we can find the relation between nth power of r squared and r. Notice that coefficients of r squared are the terms of our progression. In general, we can write r raised to the power n plus 1 is equal to an times r squared plus some constant times r plus some constant. This equation is satisfied by three constants r1, r2 and r3, which are the roots of the assumed cubic equation. Value of an, p and q are same in all these equations, and therefore it is just like a set of three linear equations having an, p and q as their variables. We can solve it using Cramer's rule. For these three equations, determinants in the denominators are same and are formed using the coefficients of x, y and z, and in numerator of any variable, coefficient of that particular variable are replaced by d1, d2 and d3. So we get an equals to the ratio of two determinants as shown on the screen. This is the general formula for nth term. Take n plus 1th power of r1 as common. r2 over r1 and r3 over r1 are less than 1, so their n plus 1th power tends to 0 as n tends to infinity. An is equal to r1 to the power n plus 1 times a constant value, and therefore ratio of an and an minus 1 is equal to r1. This makes us sure that the ratios tend to a fixed value. Let's move to our another question. X, P, Q and R are related as following, then find P ratio Q ratio R. Try this question and send us the solution, and if you have any question like this, then please share with us. Don't forget to like and share our video, and for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.